Hello everyone, here's Kanchan Handa, lecturer chemistry from Government Girls Senior Secondary School, Nehru Garden, Jalandhar. Today I will be delivering a PowerPoint presentation on Electrochemistry Chapter 3 from Class 12. The topics I will be discussing further in this presentation are the electrochemical cell, structure and working of electrochemical cell representation, finding cell potential using Nernst equation. Electrochemical cell. An electrochemical cell is a device in which the chemical energy of a spontaneous redox reaction is converted into electrical energy. Electrochemical cell is also called galvanic cell or voltaic cell. A spontaneous redox reaction is a chemical reaction in which oxidation, which is loss of electron, and reduction, which is gain of electron, are occurring side by side or simultaneously. There are two types of cells, electrolytic cell, in which the electrical energy is converted into chemical energy. And the second is electrochemical cell, in which the chemical energy is converted into electrical energy. Now, the difference between galvanic cell and electrolytic cell. A galvanic cell changes chemical energy into electrical energy, whereas electrolytic cell changes electrical energy into chemical energy. In galvanic cell, we see anode is negative, whereas in electrolytic cell, anode is positive. In galvanic cell, cathode is positive, and whereas in electrolytic cell, cathode is negative. In galvanic cell, spontaneous reaction occurs, whereas in electrolytic cell, non-spontaneous reaction occurs. A galvanic cell does not require external voltage source, whereas electrolytic cell requires external voltage source. Structure and working of electrochemical cell. In galvanic cell, electrical energy is produced by a chemical redox reaction. The cell consists of two half cells connected via salt bridge or permeable membrane. The electrodes are immersed in electrolytic solutions in each half cell, and electrodes are connected through an emitter. The electrode at which oxidation occurs is called anode, while the electrode at which reduction occurs is called cathode. For the construction of electrochemical cell, the two electrodes are taken. One is oxidation electrode and the other is reduction electrode. In oxidation electrode, zinc rod is dipped in zinc sulfate solution, which act as anode. Anode is the electrode where oxidation takes place. In a reduction electrode, copper rod is dipped in copper sulfate solution, which act as a cathode. Cathode is the electrode where a reduction takes place. In oxidation electrode, oxidation takes place. So, zinc metal from electrode loses electron and get converted into Zn2 plus ion. As it loses electrons to the electrode, so this electrode becomes rich in electrons. Thus, negative charge develops on anode. In a reduction electrode, reduction takes place. Copper ion gain electrons from the electrode and get deposited in the form of copper metal. As electrons are gained from this electrode, so this electrode becomes electron deficient. Thus, positive charge develops on cathode. Cathode is always a reduction electrode and anode is always a oxidation electrode. For example, consider a copper rod dipping in a solution of copper sulfate and a zinc rod dipping in a solution of zinc sulfate as in the Daniell cell. Both metal rod or electrode are connected through a voltmeter and the two solutions are connected through salt bridge. As soon as the circuit is completed, current starts flowing, which is indicated by deflection in the voltmeter. In this oxidation electrode, oxidation takes place, so zinc metal passes into the solution as zinc ions, liberating two electrons. Here is the chemical reaction for the same. The process involves oxidation. As oxidation is taking place, so this electrode is called the anode. In this reduction electrode, the liberated electrons move into the voltmeter and then enter the copper rod. Copper ions extract two electrons each from the copper rod and are discharged as copper metal on the copper electrode. Here is the reaction for the same, and this process involves reduction. The overall chemical reaction taking place in the galvanic cell, usually called the cell reaction. Here is the equation for the same. During this reaction, the zinc electrode will be used and the metal will shrink in size, while the copper electrode will become larger due to the deposited copper that is being produced. In an electrochemical cell, we use salt bridge. Salt bridge is a device used in an electrochemical cell for connecting oxidation and reduction half cells. Salt bridge is usually an inverted U-tube filled with concentrated solution of inert electrolytes like potassium chloride, potassium nitrate, or ammonium nitrate, etc. The saturated solution of these electrolytes are prepared in agar-agar jelly or gelatin. The ends of the U-tube are plugged with cotton wool as to minimize diffusion effects. Functions of the salt bridge. Salt bridge completes the electrical circuit by connecting the two solutions of half cells. Next, salt bridge maintains the electrical neutrality of two half cells solutions. The salt bridge provides cations and anions to replace the ions lost or produced in the two half cells, thus maintaining the electrical neutrality of the two half cells. Now here is the representation of electrochemical cell. The cell components for the zinc copper cell are a metallic copper strip immersed in 1 molar copper sulfate. Second, a metallic zinc strip immersed in 1 molar zinc sulfate. Here is a cell diagram for zinc copper cell. In a cell diagram, anode is written on the left and cathode on the right. Their charges may but do not have to be marked. The phase interface is marked by a single vertical bar. The salt bridge, which has two phase boundaries, is shown by a double vertical line. With the electrolyte, we note its molality or activity in brackets. For gas electrodes, the gas pressure or fugacity is given in brackets. A dash is written between a gas electrode and its carrier. Here is a mnemonic for easy remembrance of the representation of the electrochemical cell. We all know the further details of anode and cathode, that the position of anode is on the left and the cathode is on the right. The reaction at anode is oxidation, whereas at cathode is reduction. The name of the electrode is called anode and the name of the other electrode is called cathode. The charge of anode is negative, but the charge of cathode is positive. The movement of electrons is out of the cell from anode and into the cell from cathode. So these descriptions give rise to an easy mnemonic, that is LOAN, lone for anode, and RRCP for cathode. Electrode potential. The electrical potential difference developed between the metals and its ions in the solution is known as electrode potential. Electrode potential is a measure of tendency of an electrode to gain or to lose electrons when it is in contact with solution of its own ions. The electrode potential may be of two types: oxidation potential, reduction potential. Oxidation potential is the tendency of an electrode to lose electrons or to get oxidized is called oxidation potential. Here is an equation for the same. The reduction potential is the tendency of an electrode to gain electrons or to get reduced is called a reduction potential. And here is the equation for the same. Electrode potential depends upon first, nature of metal and its ions, second, concentration of ions in the solution, and the third is temperature. EMF or cell potential. The difference between the electrode potentials of the two electrodes constituting an electrochemical cell is known as electromotive force, EMF, or cell potential of a cell. EMF of a cell is equal to reduction potential of cathode minus reduction potential of anode. And here is the representation for the same. EMF of the cell may be defined as the potential difference between two electrodes of the cell when either no or negligible current is allowed to flow in the circuit. Here is a Nernst equation by using which we can calculate or find out cell potential or EMF of the cell. Cell potential and electrode potential depends upon temperature, concentration of solutes, and partial pressure of gases. This dependence of potential is given by Nernst equation. For a journal electrode reaction, which is given here, that is M, N positive plus N number of electrons gives M, that is metal. The Nernst equation is given as follows. In this Nernst equation, E stands for electrode potential and E naught stands for standard electrode potential for a 1 molar solution of metal ions. R is the gas constant and T is the temperature in Kelvin and F is the Faraday of electricity, where small n is the number of electrons gained during the electrode reaction. Mn plus is molar concentration of ions, where M is molar concentration of metal, Now substituting these values for R, that is gas constant, T, that is the temperature, and F, that is Faraday of electricity, the Nernst equation at 25 degrees Celsius becomes as follows. Now here is an example from NCERT for calculation of EMF using Nernst equation. The question is, calculate the EMF of the cell in which the following reaction takes place. The reaction is given as follows. And here the molar concentrations of silver ion and nickel ion are given, and the standard electrode potential of the cell is given as 1.05 volt. To calculate EMF of the cell, we are provided with the concentration of silver ions and nickel ions. And in this reaction, the number of electrons which are involved is 2. So the value of N is 2. In the Nernst equation, we substitute the value of E naught of the cell and the molar concentrations for nickel ion and silver ion. After doing the calculations of this, we will get the value of EMF for the cell, that is 0.91 volts. By giving this example of NCERT, I conclude my topic of Nernst equation. Here my presentation of electrochemistry ends, and thank you everyone for watching.